Alright, go. Good afternoon, class. Welcome back. Just settle down, everyone. So we're going to start off going over what we learnt last lesson. Now that's like, balancing equations. Remember all they have to have the same amount of atoms on each side. Like the reactants have to equal the products. So we're going to start off with that. So I've got a couple of equations here that I prepared earlier. So we've got 2 hydrogen atoms on this side, and we're plussing them with 2 iodine ions to equal hydrogen iodide. Now, this is not a balanced equation. It needs to have the same amount of atoms. So, what are we going to do? Yes?
Well, if there's 2 hydrogens and 2 iodines on one side, there has to be the same on the other side as well. So you'd have to write it H2I2.
Yep, so 2 there. Yep, so we'll just chuck a 2 there. There we go. So now it's perfect. Alright, we'll do another one. So we've got basically the same thing, just with different different elements, sorry. So we've got 2 nitrogen and 2 oxygens. Make how many nitrogen oxides? 2. Smashed it. Alright, so we'll just chuck a 2 there. Alright, now we get on to a bit harder stuff. The other way, this way. So we've got ions and oxygens and carbons. Can anyone tell me how many ions should be on this side?
2.
Yep, perfect. Alright. And then how many... Oh, wait. Maybe we should do... No, that's right. So maybe we should do the oxygens first. See how we have 2 on this side and we have 3 on this side? Mm-hmm. So if we double this one, that would make 6. So if we put a 2 here, I'll do it upside down. So if we have 2 there, that would make 6 oxygens on this side. To make 6 oxygens on this side, how many would we need?
3 on the front.
3. Perfect. Alright, and now, because we've added that extra 2, we're going to... how many do we have here?
4.
4, perfect. So we need 4 on that side, so I'm just going to chuck a 4 there. And that is a balanced equation. Alright, now we have one last balanced equation. Yeah.
Did you forget to do the carbon?
No, there's only 1 carbon on each side.
Oh,
The other one. No, there was only 1 carbon this side, 1 carbon this side. Oh wait, no, there's 3 there.
Oh, hey!
Oh, hey! Picked it up. Thank you. Sorry, I haven't done that one yet. Now we've got... Flip this over. So we got... I can't remember which one I started with this one. So we might start with the carbons this time. So we got 3 on this side. So we put a 3 over that one. 3. Alright, and then we have 8 hydrogens here. So how many hydrogens would we need over here?
Is it 4, miss?
Sure is. Alright. And then we have 6, and then we have 4, so we have 10 on this side, 10 oxygens on this side, and so we're going to need how many oxygens on this side?
Is that 5?
5, perfect.
Yay!
Nice.
Awesome, that's all of that we're going to do. Now we're going to talk a bit about what we're going to experiment on later. Here I have a propane molecule, and I also have just the 1 oxygen, so we're still doing this equation. And so when it goes under reaction, all of these little bonds, they break, and they release off energy. When these are happening, like all this heat is released as well, and yeah, they just break. And then when the bonds are forming, heat is absorbed from the surroundings, and Yeah, it's absorbed, and so it is a decrease in energy, and it makes a water molecule. And so the big thing to remember is, when we have more bonds breaking on the reactant side than on the product side, it is going to give off heat, so there's going to be a temperature increase, and then if there is more there is more bonds breaking on the product, more bonds forming on the product side than on the reactant side, there is going to be a temperature decrease. So that's basically what we're going to be doing in our experiment today. So there is one reaction, we don't know which one is which. There's one reaction where it's going to give off heat, so therefore the temperature is going to decrease, and there is also going to be a reaction where the experiment gives off heat, so it will feel really hot to the touch, and so the temperature will go up. Alright, so when the bonds are breaking, they release energy, and so they release energy and they release heat. When the bonds are forming, they absorb energy to form the bonds, and that means they absorb heat, therefore a heat change. So in the experiment we will be doing, there is two reactions. One has a heat change and it goes, like, the heat change decreases, and then the other one, it increases, so it lets off heat. A way to visualize that is when the bonds are forming, it goes up a little bit and then it makes a huge decrease as the products form. Okay, and then the other one, so all these bonds are breaking and only a small amount of bonds are forming, therefore a huge energy change, therefore absorbing more heat to be able to do it. Other than that, I think that's about it. We can jump straight into the experiment.